Hello, I will be doing assessment video 9b. So the problem states, for this problem, start with the equation below, which is this equation. And we have to solve a small block of mass M is hung from a rope and released. It begins to move downward, pulling a larger mass, capital M, along the horizontal surface with some kinetic friction given by the coefficient of friction. Derive the block's velocity just before it hits the ground in terms of the masses, h, coefficient of friction, and any other relevant constants. So there's no mathematical work here. We just have to derive in terms of these values. So what we know is that the work is equal to force times displacement. And we can look at the work done on the big box M. If we draw a diagram, we can see that there's kinetic friction pulling it backwards. There's normal force. And then there's gravity. So we know that the friction force is equal to coefficient of friction times mg. And then we can multiply that by distance. It'll be capital M. That's going to be the work. So we found W. Now we have to find kinetic energy. Kinetic energy initially is going to be 1/2 mv squared. So we have that. And then potential energy is not going to be there initially. Now on the second part of the problem, there is going to be potential energy, but there won't be kinetic energy. And also there will be no thermal energy as well, as we're finding the velocity right before it hits the ground. So let's find the potential energy. Potential energy final is just going to be mg times the height. Now we can set those equal to each other. Let's just write these as 0, 0, 0. They're negligible. Now we have 1/2 mv squared plus the work, capital M times displacement, which is equal to potential energy, mgh. Now we'll solve for V, which is what we're trying to isolate for. Solving for V, we get mgh minus the coefficient of friction times capital M times g times distance times 2, all divided by lowercase m and then square rooted. And that's going to be the velocity of the box right before it reaches the ground. And this is relevant to our current physics learning as we learn about conservation of mass and kinetic energy, potential energy, all those concepts, as well as concepts we learned in the past, such as friction force, coefficient of friction, etc. And this is just one problem that uses all these concepts, illustrates the purpose of all these concepts. Thank you.